Hello children, how are you doing? Well, I'm sure you are practicing a lot of problems at home. Alright, so today again we'll continue with our topics, last video's topic, and we'll proceed and try to complete the topic today. In the last class, you have dealt with proving root 2, root 3, root 5 as an irrational number. Irrational number, right? Even 1 by root 2 also, same methodology you apply. Alright, in that way only you prove how to prove that is irrational number. Now, let me tell you, there are actually the problems which are of this form, root A, root B, like this. Or you may come across the problem which are of the form A plus root B or A minus root B. Or you may come across the problem of the form root A plus root B or root A minus root B, right? For these kind of problems, there is one methodology of solving, right? For these kind of problems, there is one methodology of solving, and for these kind of problems, there is one methodology of solving. You have covered this variety so far. Today we will try to discuss this type and this type of problem, right? This is complicated one. These two things are very, very simple. Now, in the same perspective, let us take a problem. Prove that 6 plus root 2 is an irrational number, right? How do you prove that? See here. Very simple. It's a 2 marks question. Same. Let us assume that 6 plus root 2 is a rational number. Contradictory proof I am doing again. I want to prove something, but I am taking it is not that. So let us assume that 6 plus root 2 is a rational number. If it is a rational number, then 6 plus root 2 will be what? A by B. A rational number will be of the form A by B, right? I will write this as definition of rational number, right? Definition of rational number, where A and B are co-primes. We all know that, and all these steps are mandatory, don't forget. Now, if 6 plus root 2 is equal to A by B, then I can write root 2 is equal to A by B minus 6. Root 2 is equal to LCM is B, it is A minus 6B by B. Root 2 is equal to A minus 6B by B. This is a very, very important step of the problem. What are A and B? A and B together they are co-primes. And what are A and B? Basically A and B are integers. Now if B is an integer, A is an integer, A minus 6B is an integer. So I will write clearly A minus 6B by B. It is in the form of P by Q. A minus 6B by B, since it is in the form of P by Q, is a rational number. But what is root 2? Root 2 is an irrational. Root 2 is an irrational number. Yes or no? Why? Already proved. You can write already proved. You need not prove it here. Right? Already proved. So, left hand side you are having a irrational number, right hand side you are having a rational number. How can an irrational number be equal to a rational number? So, this is a contradiction. So, I will mention it is a contradiction. It is a contradiction. Why? A rational number cannot be equal to an irrational number. So, it is a contradiction. Therefore, our assumption is false. What was our assumption? 6 plus root 2 is a rational number, so it is false. Hence, what will I say? 6 plus root 2 is an irrational number. So children, I am sure you understood the technique how to prove 6 plus root 2 is an irrational number. Now we will move forward and we will take the next model, which is in the form of root A plus root B. Alright, now let me take a problem. Prove that root 3 plus root 2 root 3 plus root 5, anything you can take, root a plus root b form is an irrational number. This also we are going to prove with the contradictory proof. So let us assume root 3 plus root 5. Let us assume root 3 plus root 5 is a rational number. If root 3 plus root 5 is a rational number, I can write root 3 plus root 5 is equal to a by b, which is nothing but definition of rational numbers. And what is important is a and b are integers, and a and b are together, they are co-primes. So you have understood that. Now here in this kind of problem, what I am going to do is I will retain this root 5 here, and I will write a by b minus root 3. Once I write this, I will square this on both sides. I will square this on both sides. When I square on both sides, root 5 whole square is equal to a by b minus root 3 whole square. What is root 5 whole square? 5. What is a by b whole square? A square by b square plus what is root 3 whole square? 3 minus 2 into a by b into root 3. Alright. Now what do you write? I will write this as 5 is equal to, what is the LCM? B square. B square goes one time. It is a square. 1 goes b square times. So 1 into b square into 3 is 3b square minus b goes b times. So b into a will be what? 2ab into root 3. Are you clear with this? You got 5 is equal to a square plus 3b square minus 2ab root 3 by b square. Cross multiply. When I cross multiply, 5b square is equal to a square plus 3b square minus 2ab root 3. Minus 2ab root 3. This minus 2ab root 3, you bring it on the left hand side. It will become plus 2ab root 3. Now you write as a square plus 3b square minus this 5b square will go to the other side. I will write this as minus 5b square. So I will get 2ab root 3 is equal to a square. 3b square minus 5b square is what? Minus 2b square. Now I will write root 3 is equal to a square minus 2b square by 2ab. What is a? Rational number or an integer. What is b? An integer. What is 2ab? An integer. What is a square? Integer. What is 2b square? Integer. A square minus 2b square is integer. Again, 2ab is also an integer. So what you got? A square minus 2b square by 2ab. Is it in the form of p by q? Yes, sir. So I'll write a square minus 2b square by 2ab is a rational number. It is in the form of p by q. So it is a rational number. But what is root 3? But root 3 is an irrational. Root 3 is an irrational number. And in the brackets you can write proved already. Right? So I tell you again, a square minus 2b square by 2ab is in the form of p by q. It is a rational number. What is root 3? Root 3 is an irrational number, which is proved already. Left hand side you have got an irrational number. Right hand side you have got a rational number. How can an irrational number be equal to a rational number? And rational number cannot be equal to irrational number. So it is a contradiction. That's what I write. It's a contradiction. Means our assumption is false. What was our assumption? Root 3 plus root 5 is a rational number, is an assumption. So our assumption is false. Hence, what will I write? Root 3 plus root 5 is an irrational number. So this is the way you have to do these problems. Let me remind you again, there are 3 types of models you have. One are simple root a problem or root b problem. Other problems are a plus root b problem, and other variety is root a plus root b. So this model you handle in this method, this model you handle in the today's first method, and this is a different method. So in your exercise you get 3 varieties of problems which have to be handled in this way. So please take out the textbook and go through examples also and practice more and more problems, and we will see what our next topic, that is Euclid's division lemma, in our next video. Thank you, bye bye, and take care.